Welcome back everyone to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with yet another geometry course video for you guys today. And before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as hitting that bell to get notified on any of our channel's latest posts. Today's geometry topic is all about area and perimeter of basic figures. Now, I know this is quite a basic, lesson for you all, but this is a very important fundamental of geometry because we have to discover what such basic figures of geometry are before we start identifying figure relationships, angle measurements, all of these different relationships and formulas. We need to first introduce you all to the basics. And that comes with, basic figures such as triangles, squares, and rectangles. All these basic figures that you may have already known, but we're just going to highlight them by calculating a certain specific and very basic measurement, which is area and perimeter, which is probably the most basic calculation that you're going to come across in all of geometry. So it's important that we start somewhere, and then we'll start leveling up to figure classification and then specific formulas for three-dimensional figures and volumes, all of that sweet stuff. So the whole theme of our lesson today is about discovering what the basic geometric figures are and what are their area and perimeter formulas. So you might want to take notes, otherwise just mentally register this. This isn't a very hard topic, but it's good that you get at least acquainted to something like this. All right, let's jump right into it. So before we get into specific figures, we're gonna first highlight what area and perimeter are and what polygons are in general. So area and perimeter are basically two units of measures. There's two measurement calculations for any figure given in geometry, and we're going to specifically focus on two-dimensional figures, and I'll get into that later. But what I mean by area and perimeter of polygons is that a polygon, being any existent closed figure with n number of sides, is applicable to have a perimeter and area calculated. So a polygon is basically just any kind of existing shape that has n number of sides. So it's any shape that could be a square. Say for example you have a square here, like that. I'm circling it in white. That it has closed figures. It's made up of lines, so it's made up of 4 different lines, but it's also a closed figure, so it has absolutely no gaps. And any figure, I can make any random figure with curves too, like that. But this specific figure here, as you can see, it has multiple squiggles and curves. That's not considered a polygon, because what a polygon is just as it's stated here, is any existent closed figure, right? But it has to have n number of sides, but it must also have lines and vertices. Now, you cannot have a circle or any curved figure because an arc is not per se a line or a vertice. It's not anything straight. So therefore, it's considered an arc, and it wouldn't be considered a polygon. But anything with a straight straight sides and any number of them will be considered a polygon. Like I can make infinite sides that are all straight with vertices, meaning where 2 lines meet and intersect. That would be considered a polygon right here. And also you have to keep in mind that a figure, any type of shape, must have at least 2 sides. So you cannot have a figure with 1 side because that would just be a line, and that's not considered a closed figure, which is a polygon, which is by the definition of a polygon. And you cannot have a figure with 2 sides because that's impossible to make a closed figure in any aspect. But you must have at least 3 sides, and that 3-side, meaning the least amount of sides for a polygon, would be classified as a triangle, which has 3 sides. Sorry, that's bad triangle, like that. 3 sides. 1, 2, and 3. All right, let's move on to the 2 measurements that we're going to calculate. Now that we know what polygons are, which is basically a form of saying what shapes are. Polygons are any type of existing shapes that don't have curves, that all straight lines and points of intersection. Now we're going to look at the perimeter of a figure. And the perimeter is the distance around a plane figure. That's basically saying the distance around a polygon. It's the distance around a two-dimensional polygon. And I'm saying it's a two-dimensional polygon because a plane is representative of 2 dimensions. Now, you could not technically discover the perimeter around a object with a volume, which is a 3-dimensional figure, because it's not considered a plane figure, which is 2-dimensional and it's flat on a surface. And that's basically the distance around a plane figure. So it's the distance around a figure, a two-dimensional figure. Say, for example, you're having a square here. Let's say that's a parallelogram. And we're assuming that we want to find the perimeter of this figure. It's the entire distance around all of its sides, around the entire figure directly, and that's equal to the perimeter here. And it's very straightforward, and I'll get into the examples, and I'll get into visual representations so that you guys can understand it a bit further. And then we have finally our area of a figure. So it's kind of similar to the perimeter. It's a bit more complex though, and it's the number of square units contained in the interior of a figure. And I know that sounds like a bit of a complex situation here, square units being the amount of area that a figure takes up, and it's about the amount of two-dimensional space on the interior of a figure, but that's merely the amount of space a two-dimensional figure takes up. It's how much space any two-dimensional figure takes up. Say, for example, we have this triangle. We want to calculate its area. All we have to do is find out how much space it takes up. So that's basically the inside of the triangle. All right, let's move into some examples of what area and perimeter are. So let's look at the perimeter of polygons. Polygons being any two-dimensional shape, and I'll just keep reinstating that so that you guys don't get confused. So if you look here, we have this polygon because it has all of these equivalent sides, and basically what happens here is we're given a scenario where you have a perimeter here, and we have all of these side lengths on this polygon, and we're given A, B, C, D, and E. But in order to find the perimeter of that, remember that the perimeter is the area of, it's the sum of all sides, or it's the distance around a figure. So perimeter equals distance around. I'm just going to say around, but just notice it's around any figure that you're given. Around polygon. I'm going to say polygon here. Excuse me for my handwriting. Polygon, around. Okay, and it's the distance around any polygon. So in order to do that, we're going to add all of the side lengths that are given here. And basically all the side lengths added together equal the perimeter of any polygon. So we have A here, we have B, C, D, and E, and basically the perimeter is the sum of all sides. A plus B plus C plus D plus E is equivalent to the perimeter. Now let's look at area. So the area of polygons, and notice that perimeter and area can only be calculated for polygons. Perimeter can only be calculated for polygons with definite sides, but area can be calculated for any existent figure, any existent closed figure. That can be a circle, any figure with arcs and straight lines combined as well. But we won't get into that just yet. We're focusing merely on polygons with straight lines and vertices. So the area of this figure here would be basically the amount of units that it takes up. And as you can see here, we have these different units, these square units in here. And basically what you're going to do for areas, it's almost like you're counting each of every unit. So the total amount of units that's in this triangle, the total amount of these squares, which are considered square units, that's the area of the polygon, which is basically the amount of space that this triangle takes up on this graph. And there is formulas for that, and we'll get into that. But this figure here is a triangle, and we will figure out how to calculate its area. Just know that it has a formula. Area has a formula. And that formula prevents us from having to count each and every individual square. So it's basically a shortcut, and you only need specific dimensions given. So we're going to look at our first type of, we're going to look at three main basic geometric figures today. That's three geometric figures for today. And we're going to calculate perimeters and areas of specific problems for each one. So just giving you an oversight of what we're going to do now. So our first basic figure is a triangle, and I'm sure you've heard of all of these shapes before coming into geometry, but it's always good to refresh your knowledge of them. So a triangle is a figure or a polygon. Like I said before, a polygon has all equivalent, it's all sides made up of lines and vertices. It's a closed figure made up of lines and vertices. And it's basically a polygon with only three sides and three angles. So notice that in any figure that you're given, any polygon that you're given, the amount of sides is always equivalent to the amount of angles. And it's the least possible components of a polygon. So meaning that it's the least possible components for both the side lengths, meaning that it has the least possible amount of sides for any polygon, and angles as well, since angles come into direct relation with the amount of side lengths. So these are two different types of triangles, and I'll get into the figure classification later, but this is considered a right triangle since it develops and creates a 90-degree angle at its base, and this is an equilateral triangle, meaning that all of its sides and angles are equal, so it's an equiangular triangle. Equilateral. Okay, let's move on to discovering what perimeter and area of a triangle is. So this is our first problem here. We're given a triangle. Like I said before, this is all about triangle problems. And the problem that we're going to discover is trying to find the perimeter for this triangle. Now we're given that the side lengths are 3.2, 5.8, and 7.2. Now with info, we're going to calculate. And we're going to use our perimeter formula that I'm going to state here. So find the perimeter, and that's a problem. So for the solution, our first step is going to be discovering what the perimeter equation is. And the perimeter is the sum of all sides, or it's the distance around. Like I said before, it's the distance around the figure. And then what we're going to do is after we give that equation, we're going to plug in all of this information that we see here. And we can see that it has 3 side lengths because a triangle has 3 sides. And we see that they're each 3.2 feet, 5.8 feet, and 7.2 feet. So we're going to plug those into the equation for a perimeter, and we're going to substitute perimeter for p as our variable, and we're going to say that p equals 3.2 plus 5.8 plus 7.2. And after we add those together, we plug in all of our values into our equation. We're simply just going to plug that into a calculator or just write it out, and we're going to get that your final value is p equals 16.2 feet, or perimeter equals 16.2 feet. And that's the total distance around this entire triangle. Now we're going to look at an area problem here. We're given a right triangle, and I just want to state here that the area formula will only work for a right triangle because other triangles, you're not given an altitude as a side length. And I will explain that in later videos because I'll do a whole entire lesson or group of lessons on what right triangles are and what triangles are in order to differentiate why this area formula doesn't work. But just see that this formula will only work plainly if you have a right triangle, which is basically a triangle with a 90-degree angle, and that's indicated by this little square here. And so the problem that we're going to encounter first is trying to find the area of this triangle. And the first step in our solution is trying to refer to the area of a triangle, what the area formula is. And the area formula for any polygon is going to always differ depending on what the polygon is, but the perimeter formula always remains the same. So this is the area formula for a triangle, and specifically a right triangle is shown here. And it's 1/2 times the base times the height. So 1/2 meaning 1/2 as the fraction 1/2, but base and height are relative amounts in the triangle. So how we figure out the base and height, that's shown right here. So the base is, as you can see here in this triangle, it's segment OM. So it's this blue line here. The reason that it's the blue line here is basically because the base is considered the side that is perpendicular to the very top vertex, or it's the very bottom side of the triangle. You don't have to have one base for the entire triangle. It just depends on the position of the triangle. Since OM is on the very bottom of the triangle, it is considered the base. And since we have altitude or height, MN, intersecting the base at a 90-degree angle here, that is also considered the height. So we're going to plug in those values into our area equation, and we get that 1/2 times 3, which is our base, times 4 is equivalent to the area of the triangle. And we get that the area of the triangle is 6 square units if you multiply this out, or if you plug it into a calculator. And another equation, another way of writing this, 1/2 times base times height, is merely, is merely saying base times height. I'm abbreviating B for base and H for height. divided by 2. So you can multiply that, and that's by the commutative property of multiplication that you can change this around. Moving on to our next two figures, we have the squares and rectangles. So these are the next two basic figures. There's 3 that I'm mentioning today, and these are the last 2. So we have our first figure, which is a rectangle, and it's a polygon with 2 pairs of equal opposite sides. So as you can see here, this is a rectangle right here. And basically all it is a polygon with 2 pairs of equal opposite sides. These 2 lines that are marked on each side, like say for example this side with 1 arc and this side with 1 arc, that shows that they are equivalent, and these sides are equivalent. So these opposite sides that are opposite from each other are equivalent in length, and a rectangle is also indicated as shown here has 4 right angles. And I will go into depth what 4 right angles are, but a right angle is just shown by a square in a corner. Basically, that's simple as it can be, and it's just representing that it is a right angle. And finally, we have a square here, and it's basically just a type of rectangle. It's a certain type of rectangle, but it has all equivalent sides. Now, a rectangle only has 2 pairs of equivalent sides, but a square has all equivalent sides, but it also has all the same properties. Since it has all equivalent sides, it has equivalent opposite sides as well as 4 equal angles. So let's get into perimeter and area of rectangles and squares. So we have first here a square, because the reason that I didn't show a rectangle in this process is because a square is a specific type of rectangle and it represents both sides. It has the same exact area and perimeter equations. So our problem for today is trying to find the perimeter first of the square and then finding the area. Now notice the square is also a rectangle, so it's the same thing as finding the area of this rectangle. And the solution to that is, first, we're going to find the perimeter. Since we already know the perimeter equation, it's the sum of all sides, I'm just going to go ahead and plug in all those values into our equation. And we see that the square has 4 equivalent sides of 3 inches, and that can be represented by 3 plus 3 plus 3 plus 3, which equals 12 inches. But since a square automatically has 4 equivalent side lengths, you can just merely multiply the side length by 4. So it could be 4 times 3 equals 12. That's another way of writing it. And now we're going to find the area of this figure. Now, the area of a rectangle and a square, they have the same exact area formula, and the area for any square, including a rectangle, is length times width. So that's also for a rectangle. I'm just going to write that here. Also for rectangle. And what a length is basically how long a figure is and how wide a figure is. Now you have 2 lengths on any figure, and this basically here, like I'm showing here with my mouse, this side here is considered a length, and this side here is considered a length. Opposite sides are both the same type of dimension for the square, saying that this side and this side are both lengths, and this side are both widths. But the length and width are interchangeable. So as long as they're both the same for opposite sides, the length and width can be any side of the rectangle, of the square. And we're going to just say that this side is the length, because normally the side on the left is always the length and the side on the top is always the width. And just the easiest way to figure out what length and width are is you choose any side on a square or a rectangle, and you call it your length. So say, for example, let's use this as an example. Let's use this side. We'll pick this side. And any side that intersects this side length at a 90-degree angle, this side intersects at a 90-degree angle, and so does this side. Those both can be considered as widths because they're both equivalent sides. So we're going to plug in our values to that equation, and we're going to find out that 3 times 3 is 9 square inches, and 3 are both our lengths and widths. So we have 9 square inches. And the reason I say square inches is because when you have area, it equals the amount of units, which is basically the amount of space a figure takes up, squared. Since it's not just one linear dimension, it's actually a whole squared dimension. It's a quadratic dimension. And this is a rectangle here. Like I said before, it's the same exact properties as a square. So we're going to find the perimeter first, since we already know the perimeter formula. That's okay. And we're also going to find the area of this rectangle, as we already have been introduced. Since the area of a rectangle is just the same exact area of a square. So we're going to find our perimeter equation. It's the sum of all sides. So we're going to add all of our side lengths, which is 6 plus 8 plus 6 plus 8, and that equals 28 meters. Now, what you can also do is, since you know that a rectangle has two pairs of equivalent sides, we can merely just do 2 times 8 plus 2 times 6, or which can be the 2 times the length plus 2 times the width. And we're going to add those and simplify to get 28 meters. And then we're going to find the area of the rectangle, which is, of course, length times width. And like I said before, you can choose any side of this rectangle and just see any side that's completely adjacent to or forms a right angle to. So we're going to choose 8 as our length and 6 as our width because they both intersect at a 90-degree angle. And we see that 8 being our length and 6 being our width multiplied by each other equals 48 square meters. And just to refer back to our area property, you must refer to it in square meters. And finally, I'm just going to show you a bit of an irregular polygon. This is just a random polygon that I showed with 5 sides. It's not necessarily characterized as a specific polygon, but I just wanted to get you guys acquainted to these equations of area and perimeter. So we know that perimeter is, we're just going to calculate the perimeter for this figure because I don't want to get into calculating the area yet, because this would be turned into composite figures. So I'll develop an entirely new lesson all about composite figures. But we're just going to calculate the area since we know that the area is simple and it's merely the sum of all sides of any figure. So we're going to discover all of the sides of this figure, which is 1.4 plus 3.2 plus 5.1 plus 3 plus 5. As I said, we're going to add all these sides, and we get an answer of 17.7 centimeters. And always make sure that you look at the units of measure that your lengths have, because you always want to put that as your final answer, because it's a total of 17.7 centimeters. You can't just say 17.7 blank. Even if you're not given a measure of length, just say units, because units is a very general term, meaning any unit of measure, any term of measure. So that'll be it, guys, for today's lesson. Thank you guys for tuning into eCoreAcademy. Please make sure to like and subscribe as always, and hit that notification bell to get notified on any of our channel's latest posts at eCoreAcademy. Please visit our website at eCoreAcademy.org to get full access to our unlocked integrated notes, quizzes, and worksheets that go along with each and every single course video on our YouTube channel. And if you want to, please reach out to us at our Gmail at eCoreAcademy@gmail.com. If you have any questions, or if you just want to, reach out to us, we'd be more than glad to communicate with you. And we have our other socials in this box below, being Facebook, Instagram, and Twitter. So please make sure to follow there. We have all of our stories and our videos linked there as well. So I hope you guys enjoyed this little basic video for you guys. It's very important that we unlock the fundamentals of geometry before getting into the complexities of it, because I don't want you guys to get confused in the future to come. So hope you guys enjoyed. It's been AJ here, and I'll see you guys in the next one. Peace.